Why these affordable sedans are actually dangerous financial traps. That reliable budget sedan sitting in your driveway right now is hiding a catastrophic secret that could cost you thousands of dollars, and most owners won't find out until it's too late. We're talking about plastic coolant crossovers engineered to disintegrate under normal operating pressure. We're talking about CVT belts that seem almost designed to fail right after the warranty clock runs out. And we're talking about an entire category of vehicles marketed as affordable that are, in reality, a countdown timer to a repair bill bigger than the car's own resale value. You didn't just buy a commuter car. You bought a ticking time bomb with a payment plan attached. Stick around, because by the end of this video, you're going to understand exactly why so many of these budget-friendly sedans turn into money pits and how to spot the warning signs before you sign the loan paperwork. Every year, automakers roll out a fresh crop of sedans marketed almost entirely on one number: the sticker price. $20,000, $19,000, sometimes even less. And on paper, that looks like a win. Low cost of entry, decent fuel economy, a manufacturer warranty that sounds reassuring. But here's what almost nobody tells you in the dealership showroom: the sticker price is not the real price. The real price is what you pay over the next 10 years in maintenance, in repairs, and in the diminished resale value of a car that develops a reputation for falling apart. This isn't a video about any one brand being bad. This is bigger than that. This is about an industry-wide pattern, a set of engineering decisions made across multiple manufacturers that consistently show up in the most budget-oriented trims and models. Decisions that prioritize faster assembly line throughput, lower unit material costs, meeting emissions and weight targets over long-term durability. And when you understand why these decisions get made, you'll start to see the pattern everywhere, not just in one car, but in an entire class of vehicle. So let's tear it down, system by system. Let's start under the hood at the cooling system, because this is ground zero for one of the most common budget sedan failure points. In a lot of higher-end or older generation engines, coolant crossover pipes, the components that route hot coolant from the cylinder head to the radiator or thermostat housing, were made from cast aluminum or even steel. They were heavy, sure, but they were also durable enough to handle decades of thermal cycling. Somewhere along the way, as automakers raced to shave curb weight and shave manufacturing costs simultaneously, a lot of these coolant carrying components migrated to composite plastics, glass, filled nylon. Mostly, and on paper, that's not inherently a bad engineering choice. Plastic composites can be engineered to handle high heat and pressure. NASA uses composites in rocket nozzles, for crying out loud. The problem isn't that plastic is used. The problem is how thin these components get made and what they're exposed to over the life of the vehicle. Here's the mechanism of failure, step by step. 1. Thermal cycling. Every time you start your car cold and drive it until the engine reaches operating temperature, sometimes 220 degrees Fahrenheit or more, inside the cooling system, that plastic crossover expands. Then it cools back down and contracts, over and over, thousands of times over the life of the car. 2. Coolant chemistry degradation. Most coolant is only rated to maintain its corrosion-inhibiting properties for a set interval, often 5 years or 100,000 miles for the long-life formulations, less for conventional coolant. Once those inhibitors break down, the coolant becomes mildly acidic. That acidity doesn't just attack metal components, it can also degrade the resin matrix holding the glass fibers together in a plastic crossover. 3. Vibration and mechanical stress. These crossovers are frequently mounted directly to the engine block, meaning they experience every vibration harmonic the engine produces for the entire service life of the vehicle. 4. UV and heat exposure from adjacent components. Sitting inches from the exhaust manifold or turbocharger in some transverse-mounted engine bays, these plastic components are baked from multiple directions simultaneously. The end result? A component that was engineered to a cost target and a weight target, not necessarily a 200,000-mile durability target, begins to develop micro cracks. And here's the part that turns an annoying failure into a genuinely catastrophic one. When a coolant crossover fails, it usually fails without warning, at highway speed, under load. You're not going to get a slow drip that you notice in the driveway. You're going to get a sudden pressure release, a cloud of steam, and a temperature gauge that spikes into the red before you can even find a safe place to pull over. And if you don't catch it in time, you're looking at a warped cylinder head, blown head gasket, or in the worst cases, a fully seized engine. Repair cost for a full cooling system failure with secondary engine damage, anywhere from $1,800 for a straightforward crossover and hose replacement, up to $4,500 or more if the overheating event damaged the head gasket or warped the head itself. On a car that's worth $6,000 on the used market, that math doesn't work in your favor. Now let's talk about the transmission, because if the cooling system is where budget sedans die suddenly, the CVT is where they die slowly, expensively, and often right after the warranty expires. Continuously variable transmissions became the darling of budget sedan engineering for one simple reason: fuel economy. Unlike a traditional automatic with fixed gear ratios, a CVT uses a belt or chain running between two variable diameter pulleys, allowing the transmission to select an essentially infinite range of ratios. That means the engine can operate closer to its efficiency sweet spot more of the time, which translates directly into the EPA fuel economy numbers plastered on the window sticker. Manufacturers love CVTs for the sticker. Consumers, several years down the road, often hate them. The heat problem. CVTs generate significant heat through the friction of the belt or chain against the pulleys, especially under load. Think merging onto a highway, climbing a grade, or towing anything. Traditional automatics dissipate heat well because they've had nearly a century of engineering refinement. Many budget-oriented CV applications were given cooling systems sized for typical commuter use, not sustained high-load operation. When the transmission fluid overheats past its design threshold, it breaks down chemically, loses its lubricating properties, and accelerates wear on the belt and pulley surfaces exponentially. The belt-chain wear problem. The steel belt or chain is under constant tension and constant micro-slippage by design. That's literally how the ratio changes. Over tens of thousands of miles, this creates gradual wear that most drivers experience as a shudder, a whine, or a hesitation under acceleration. By the time it's noticeable, the internal damage is often already extensive. The fluid problem. CVT fluid is a highly specialized formulation. It's not interchangeable with regular ATF, and it's not cheap. Worse, many owners don't even realize their CVT needs a fluid change at all, because several manufacturers historically marketed these transmissions as requiring lifetime fluid with no scheduled service interval. Independent transmission specialists across the industry have widely disputed that claim, and several manufacturers have since walked it back or issued extended interval service bulletins after widespread failures. The planned obsolescence argument, let's be fair about this. Is a CVT literally designed to fail at 80,000 miles? No credible engineer would sign off on a component with an intentional failure date. That would be an enormous liability and warranty exposure for the manufacturer. But here's where the criticism does land fairly. When you build a transmission with a fluid cooling capacity sized for light duty, a lifetime fluid marketing claim that discourages proactive maintenance, a repair philosophy that requires full unit replacement rather than in-shop overhaul, you have created a system where the economically rational outcome, from the manufacturer's perspective, is a transmission that lasts just long enough to get great fuel economy numbers during the sales window, and just long enough to clear the powertrain warranty without necessarily lasting the 200,000 plus miles that a well-built traditional automatic or manual transmission can achieve. Whether that's malicious intent or just the predictable result of cost-optimized engineering is genuinely debatable. But the outcome for the consumer is identical either way. A transmission replacement that costs $3,000 to $5,500 on a car that may only be worth $7,000 to $9,000 total. That's not a repair. That's a financial event. Moving deeper into the engine bay, let's talk about timing systems specifically. plastic timing chain guides, and hydraulic tensioners. In an effort to reduce noise, weight, and cost simultaneously, a significant number of small displacement, budget-oriented engines shifted away from all-metal timing chain guides toward composite plastic guides and towards simplified single-stage hydraulic tensioners instead of more robust multi-stage designs. The failure pattern here is almost boringly predictable. 1. Engine oil, especially if service intervals are stretched, which budget car owners are statistically more likely to do, carries more contaminants and loses viscosity control over time. 2. That degraded oil reduces the effectiveness of the hydraulic tensioner, which relies on oil pressure to maintain proper chain tension. 3. As tension slackens, the chain begins to slap against its guides during normal operation. 4. The plastic guides again, chosen for cost and weight, not maximum durability wear down, sometimes shedding small plastic fragments directly into the oil pan. 5. Eventually, either the guide fails completely, the chain jumps timing, or in the worst-case scenario, a piece of the failed guide gets ingested into the oil pump pickup, starving the entire engine of lubrication. The audible warning sign is a rattling noise on cold start that disappears once the engine warms up and oil pressure builds. Almost every owner ignores this the first several times they hear it, because the car seems to run fine once it's warmed up. By the time the noise persists through the whole drive cycle, the damage is frequently already severe. Repair cost for a proactive timing chain and guide replacement, $600 to $1,400, depending on engine layout and labor complexity. Repair costs for a reactive replacement after the guide fails and causes secondary damage, full engine replacement, frequently $4,000 to $7,000 installed. That's not a 10 times cost multiplier by accident. That's the gap between maintenance and catastrophe. Budget-oriented vehicle architectures frequently rely on a dense, interconnected network of relatively cheap, single-point sensors, oxygen sensors, mass airflow sensors, camshaft and crankshaft position sensors, feeding data into an engine control module that has very little tolerance for ambiguous or degraded signal input. Individually, these sensors are inexpensive. A mass airflow sensor might run $60 to $150. An oxygen sensor, $40 to $100. Cheap, right? The problem is, what happens when the engine control module itself can't reliably distinguish between sensor reporting bad data because it's failing and sensor reporting bad data because something else is actually wrong. In a lot of budget ECU calibrations again, optimized primarily for cost and emissions compliance rather than robust diagnostic logic, a single degrading sensor can trigger the module to enter a defensive limp mode, pull ignition timing, richen or lean the fuel mixture incorrectly, and in some documented cases, trigger a cascade of secondary component wear that wouldn't have happened if the system had simply flagged the original sensor and left everything else alone. The result, a driver takes their car to an independent shop for what should be a $70 sensor replacement and walks out with a $1,200 bill because the shop discovers that 6 weeks of the car running on a bad signal has already damaged a catalytic converter, fouled spark plugs prematurely, or accelerated wear on an already marginal transmission solenoid. This is death by 1,000 cuts, and it's a direct consequence of engineering a control system to the minimum viable diagnostic standard, rather than a robust one. Let's put all of this together into a number, because that's ultimately what matters to your wallet. Say you buy one of these budget sedans new for $21,000. Over a typical 8-year ownership window, here's a realistic accumulation of the failure points we just covered. Assuming average, not worst case luck, cooling system crossover replacement around year 5, $2,000. CVT fluid service neglected, transmission replacement around year 7, $4,200. Timing chain guide wear leading to proactive replacement around year 6, $900. 2 to 3 sensor cascade related repair events over the ownership period, $1,800 combined. That's $8,900 in repairs on top of your original purchase price And that's the optimistic scenario, where nothing catastrophic happens simultaneously, and you catch problems before they compound into engine or transmission replacement. Now compare that to the car's actual resale value at year 8. A budget sedan with this repair history, even if fully repaired and well documented, is going to appraise dramatically lower than a comparable vehicle with a cleaner mechanical history. Because used car buyers, and more importantly the algorithms that dealers use to generate trade-in offers, are increasingly sophisticated about flagging these exact failure patterns by make, model, and model year. You didn't buy a $21,000 car. You bought a $30,000 car disguised as a $21,000 car with the extra $9,000 hidden in a payment schedule you didn't sign up for, deferred, unpredictable, and always arriving at the worst possible time. So what do you actually do with this information? A few concrete steps. 1. Research the specific transmission and cooling architecture before you buy, not just the brand. 2 sedans from the same manufacturer can have completely different reliability profiles depending on whether they use a traditional automatic or a CVT, and depending on which engine family they're paired with. Look up technical service bulletins and class action or NHTSA complaint databases for the specific model year and powertrain combination, not just the nameplate. 2. Never trust lifetime fluid claims at face value. If a manufacturer says a transmission never needs a fluid change, treat that as a marketing claim, not an engineering fact. Independent transmission shops overwhelmingly recommend CVT fluid services every 30 to 60,000 miles, regardless of what the owner's manual says, and this single habit is one of the cheapest insurance policies you can buy against a 5-figure repair. 3. Get a pre-purchase inspection from an independent mechanic every single time, even for a reliable model. A 30-minute inspection that costs $150 can reveal early warning signs of coolant crossover weeping, timing chain rattle, or CV shudder before you're financially committed. 4. Budget for the real cost of ownership, not just the loan payment. If you can't comfortably absorb a $2,500 unplanned repair within the first 3 years of ownership, you may be more exposed to this trap than the sticker price suggests. 5. Watch for the early warning signs covered in this video: cold start rattles, hesitation or shudder during acceleration on a CVT, any sweet smell suggesting coolant vapor, or a check engine light that keeps returning after a sensor replacement. Catching these early is the difference between a $400 repair and a $4,000 one. Look, none of this means every budget sedan is a disaster waiting to happen. And it doesn't mean every owner will experience every failure we covered today. Plenty of these cars run for 150,000 plus miles with nothing more than routine maintenance. But the pattern is real. It's documented across multiple manufacturers and multiple model years. And it disproportionately shows up in vehicles engineered primarily to hit an attractive price point rather than a maximum durability target. The takeaway isn't never buy an affordable car. The takeaway is know exactly what you're buying, budget for what the sticker price doesn't tell you, and never skip the maintenance that manufacturers quietly hope you'll forget about. If this kind of deep dive teardown is useful to you, let me know in the comments which specific model or system you want us to tear down next: engine, transmission, or something else entirely. And if you're currently shopping for a budget sedan and want a second opinion before you sign anything, drop the model and trim in the comments, and we'll do our best to flag anything you should watch out for. Thanks for watching. We'll see you in the next one.